Continuing on our journey of exponents, here we go. We got the power of a product right here. What does this mean? It's kind of like the distributive law. You notice that this is brackets here, and you know to distribute this to this one and this one. So this actually means x to the m, y to the m. That's kind of cool. Easy peasy too. Same goes with this. This is also, even though it's a quotient, this still means distribute. Distribute up and distribute down. So this becomes x to the m over y to the m. Interesting. And let's look at the last one. The last one is the power of a power law, which again, because there's a bracket, you know to distribute, which actually you know means multiply. So this is x to the m times n. That's really important to see that this is in fact multiply. And what tells you that is this bracket. Remember, when you're going across a bracket, you always multiply. So I got a couple of questions for you here. Look at this mess down here. Oh my goodness, what? Oh, it's horrible. Let's clean this guy up before we do anything. First things first, I'm going to work from the outside going in for a second here. And I want you to notice that that's a multiplication one. So we've got negative 4/5 now to the negative 6. Why? Because that's 2 times negative 3. That's across the bracket. It's multiplication. Then we're going to divide. Okay, so why don't we just put this as a division right now? This is negative 5 times 4. So again, we have negative 4/5. That's our base, to 4 times negative 5, which is negative 20. And look how simple this becomes now. This becomes one of those, look at this, division quotient ones, where you just have to subtract. So this becomes negative 4/5. Notice how the negative stays the same. The negative 4/5, the base does not change, but the exponents do. That's the important thing to realize. Okay, negative 6 minus a minus 20. There's that negative thing again, which you know is negative 6 plus 20, which works out to be negative 4/5 to the 14. That would be your answer. Done. And unless it says to evaluate, leave it like that. Take a look at this mess. Found another one. Remember, this is on the outside. So that means it gets distributed to each one. Yes, even the 25 becomes 3/2. So now we're going to have to remember our flower power for that. Oh, what a mess. This is going to be a to the 4 times 3/2. This is going to be b to the 2 times 3/2. Well, you know what? Let's deal with this guy first. Let's deal with him first. We know that flower power tells you that this is the power, that's the root. So this is the square root of 25 to the power of 3. The square root of 25 is 5. To the power of 3, 5 times 5 times 5 is 125. Holy smokes. Now, let's look at this one. 4 times 3, well, wait a second. 4 times 3, how can you do that? Well, it's a fraction. 4 times 3 is 12. 1 times 2 is 2. You actually have a 12/2, which is actually a to the 6. So let's put it down here next to the 125. Now, I know some of you are saying, well, wait a second. Why did you do it that way? Why couldn't you just used cancellation law? Well, we'll do cancellation law on this one. Okay? You know that that's 2/1. You know that these guys are multiplied against each other. But look, 2 and 2 cancel, leaving you b to the 3, right? Which your answer then would be b to the 3. Really straightforward, some really tough questions, but if you break this down nicely, you'll see that these answers are actually quite easy to do.